What's good, YouTube? It's your boy Andre King coming at you today. And in today's video, we're actually going to give a lengthy answer and a demonstration to this question from Black Cloud Geeks 6439, who asked, I don't understand how you came up with the next top IP addresses. And this is in reference to one of our videos deploying the Palo Alto VM series firewall in AWS. And so let's go with the book answer and kind of show, I won't say our best friend, but our trusty old Google. And we'll say AWS reserved IP addresses, and we'll say in the subnet. I don't know what this will come up with, but we see here IP address. Like the true answer is that not only for our Palo Alto VMs, but any virtual firewall that we were to put in AWS, there's these reserved IP addresses, 5 to be more specific, and one of those is actually the answer that we always need to remember. So if we scroll down, we see here they're discussing a hypothetical CIDR of 10.00.128/25. Well, 10.000/24 when they kind of give the answer. And the very first IP, similar to when you're studying for, CCNA and subnet and things like that, the network address. So in this CIDR range, the .0 is our network address. And it's that next one, this .1, that is reserved by AWS for the VPC router. So really for any subnet, that .1 address, and you'll hear many engineers that are in the AWS arena, even if it is that hypothetical, this one right here, 10.00.128/25, the true router or default gateway for that subnet is +1 of the network. It's .129, but they'll still reference that or call it the .1 address, and that's what they mean. Just add one to the network address. We won't discuss these other three that are reserved for the purpose of this video. So the tail end is just having that back end knowledge and knowing that here as you get more kind of hands-on experience, like for anything that you're deploying in AWS by default, that's going to be the answer that we need to leverage. So if we go into our firewall, the cheat code or the answer, like I said, this is actually that firewall. We spun it back up from for the series. But if we go to our network tab and from our interfaces, as long as we don't change it to static IP, we just use dynamic or DHCP. There's the API calls, which are beautiful. That actually they give you the answer. So for ETH11, AWS is telling us in the Palo Alto's management console that the gateway is 10.0.1.1. And these are more unique cheat codes between the two, where again, you'll see that it's providing the same answer for code 03 and code 54. So the same holds true for um, the ETH12, where the gateway is 2.1. So that just reinforces or validates that that theory or that notion of using the subnet's gateway IP is the one. And you may ask, like, even if that doesn't make sense, like, okay, well, that's telling me which one to use, but I still don't get it or understand, like, why would you use that? We'll do a real quick sketch, again, using my mouse, no pencil, epic pen or anything here. But let's quickly just draw, let's say, we'll call this the firewall, and we'll use shorthand notation. Let's say this is our outside interface, ETH11, and we'll give it that IP address. Let's say this is 0.100, and then let's go purple on this side. This is inside. This is ETH12, and this is 1.100. And then let's say there's I don't know, a server down here. Let's say it's in a completely different subnet. Call it SVR. And let's say it's got, I don't know, 8.100. That part is not too relevant. But it depends on the flow of traffic. So if we're speaking, let's say, I don't know, we're only speaking when it comes to the RFC 1918, the private. Let's not worry about the NATing, the internet gateway, etc. But traffic's coming in destined for that server, and the NATing is already there in place. So when traffic hits this outside interfaces, it's going to consult the firewall's route table that says, how do I reach 8.100? And without a static entry, or even if we were using DHCP, let's keep it simple, not DHCP, but a dynamic IGP, an Internet Gateway Protocol. We still need to know how to get that so that we don't drop traffic. So if we had a static entry, and in that video, that's where we said, well, to reach, in this case, we could say basically we could do the ugly way that a lot of people do the oh, it's terrible. We're not specific at all, which is permitting too much traffic. But to reach anything that's not more specific or that I know about, like send that out interface ETH 1.2 and then send it towards 1.1. That's where this comes into play, that question, like, how do we know? And I call it, and if it's not imaginary, I call it the invisible router for AWS. That's for each subnet, which in this case, the third octet, we need to send that to the 1.1 invisible router. And then through logic, it'll know how to get here. You still need the remaining, whether it's transit gateway, if this was in another, well, actually, this would be in the same VPC, but you need that route table entry to get it there. But again, in the opposite direction, the same holds true. The server now wants to reach the internet. So when traffic gets all the way to this outside interface, this 0.100, it's going to need its next hop IP, and it's going to need entry just like this. That's where that quad zero entry comes into place for all unknown destinations. It will point to ETH 1.1, and the next hop will be 0.1 to get it on its way towards the internet. So that's the long and short, kind of drawn out way of why we need these routes in the route table of the firewall. And then, of course, how it ties together with that. Again, I call it the invisible router from AWS. I say invisible because just like entries of like an internet gateway, unless you're using a WAF, like you don't have any visibility kind of into what's going on there. There's no route table. AWS is not telling you like what's hitting these IPs right there. So let's do that imaginary thing again. Let's get into, let me pull up AWS, and hopefully I don't think you need to restart the router. Let me do like I always do, open another VPC tab. Let's create a new subnet. Let's see, I think these are all, let's see. Let's see what this VPC is. I think it's a /16. It is. All right, so let's go subnet. And then again, we got that production server. Let's sort. So we got 0.1.2. Let's create a subnet. We'll use the same role prep. This is in availability zone. I think it's in, yeah, 1A. So let's create the subnet, the only VPC we have here. And we'll name this test. This is in 1A. And we'll give this 10.03.0/24. And the name tag is there. Do 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 do. 0.1.2. Do we have a? Didn't think we had a. Oh, that server subnet is in the same VPC. I thought it was separate. No worries. So now that we have that, let's go back to our EC2 tab. Let's go to network interfaces. Let's create this one we won't worry about. Well, let's see, name Palo. Well, I guess we will, for the sake of consistency, naming. We'll create a network interface. We'll give it the name test, which is for that subnet. We'll type test to filter. We'll select that. Auto assign, we'll do custom 10.0.4.100 security groups. This part we don't really care about now. name tag. We'll name our interface. Yeah, actually, yeah, that's cool. All right, so now that that's created, it's all right there. Test. Let's go to actions. We will associate this address. Oh, not associate. Sorry, that's for the public side. Um, all right, so we'll go to instances, Palo Alto, actions, networking, attached network interface. We'll select production VPC, test, and we will select attached. All right, so we'll refresh this. And then if we come underneath networking, this should now be visible. We do see it there, the 4.100. If we scroll down, the index is 3, counting canonically. All right, so now let's go back here. Let's add the Ethernet interface. We won't do a comment. Let's just quickly get this one up for the sake of time. So IP, we'll select DHCP. We won't create a default route. And let's do and virtual router default. Do we need a new zone? Let's just make one. We'll call it test. Say OK. And we'll hit OK. All right, so let's commit this change. This is adding third interface test. All right, so we'll wait for that to come up. And like we said, this again is just to show, actually, it doesn't matter if we would have created like a /25, which actually that's what I should have did to demonstrate that it's not always .1, but in that case it would have been .129. So that's a challenge. More so if you're a naysayer, you think somehow this is some magic weird .1 is shown. Just create like a anything less than a /28. You get your /27 or whatnot, and just see what that IP comes out to be. All right, so we got the red there. Let's see what we got here. All right, let's see. Hopefully we don't have to reboot. We may have to be quite honest. There may be a CLI command to refresh that. Yeah, that interface isn't coming up, although the push is there. All right, so we're gonna do that. We'll gracefully or non-gracefully restart this device. All right, so all right, so I'll sit here and like I said, we're not gonna what do you call it? Configure anything else, but we'll fast forward through and we'll see when it comes back up that it's just validating that that's truly not anything that we're entering or manipulating to make that API call provide us dynamically with the gateway. So We'll be back here shortly. So here we go. We're back here in action. Firewall is back up. And it took about, yeah, maybe 4 minutes. Raise this table. Tired of that little squeaky, squeaky noise there. Let's see. Yeah, let's see that. There we go. All right, so yeah, this was the last commit before we restarted it, adding that interface 3. So now if we come back to networks, hopefully we're green. All right, so we're all green up there. We saw early in the video for the existing interfaces, ETH 1.1 and 1.2 there, but moment of truth, and there we go. 4.1. So again, just through the API calls on the back end, this is where you also could have gotten that answer. So it's always best, like I say, to learn and know and recall, not to say remember, but keep with you those network fundamentals. And so in AWS, at least, that's where the default router ID or IP is going to be for each subnet. I know their documentation, they're speaking more for the VPC router, but the same holds true for each and every subnet. So hope you guys found some value in today's demonstration. Apologies that we needed to reboot our router there. Like I said, there's probably a CLI command that we could have did to restart the management plane or something. Well, actually, I know the command to do that. That's normally when Panorama's fudged up between committing properly with templates and stuff. But I actually haven't tried that. I'll have to try that offline and let you know if that will work. But like I said, let me know down in the comments if you found value. If you got any other questions, keep them coming. And thank you so much to our contributors today, Black Cloud Geeks 6439, for not to say sponsor today's video, but to give us the content for today's video. So keep the ideas coming. But until next time, stay safe, take care of yourselves, and peace.